audible to you guys? Is there any issue with my audio?
So you are audible, but your voice is not clear.
Can disconnect my internet connection and get back to you again. Probably it might help.
Hello. So is it fine now?
Yes, sir.
Yes, sir.
Okay. So what I am saying is we say that the convergence will be there, and initially we put that okay ki our initial guess should be sufficiently close to our exact solution so that we can have a good control on the derivative. Because when you go on the fixed point iteration theorem, so let me share my screen. So when you go to the theory of fixed point iteration theorem, it is nothing but this, right? So g of xn. So if I say it is say g of x of n plus 1 minus g of xn is less than equal to g prime sum c mod xn minus x of n minus 1, right? This is how we are finding the root. So this is a basic theory for a fixed point iteration method that we okay. And if we can control this derivative, so if we say that mod g prime of c is less than 1 in some neighborhood, say it is your exact root a, and in this neighborhood, if your g prime c or g and g prime okay, so say it is a minus epsilon, it is a plus epsilon. So I say that g prime c mod is less than 1 for all c in a minus epsilon comma a plus epsilon, then I am through, right? So this is the theory. But we say all these things like we say that okay, my initial guess x naught should be somewhere here. Why do we say this? So that we can control my g, so that I can control my g prime. Okay, so that is the only reason we say that our initial guess is sufficiently close to my root. Okay, because if I say it, this is my axis, this is Okay, so this is my exact solution. So g of a is equal to a. Okay, and say you start with this here x node, but at this x node you can't control g, or your g prime is getting sufficiently large and you are not getting the convergence. Okay, am I making sense to you? The why in the definitions we say that we should choose our exact solution to be sufficiently close, but it is not the necessary condition, it is a sufficient condition, we should say. Does this make sense?
Then sir, how to show that here this iteration will converge actually? Is it
That
by finding iteration, calculating iteration, then we'll see that it is converging or not?
see, you have two methods here. In question number 3, first of all, one thing you can start with this. You have all okay, my p is exact solution. Okay, so one method is you can start, this is a definition that we want to find p minus pn in terms of some p minus p of n minus 1, right? Some power alpha say. If you can we can show that for all n sufficiently large enough, then we can say that the order is alpha, order convergence is alpha, right? So one method is you have the exact solution as 21 to the power 1 by 3, so it is your p. So apply p minus pn in abcd part and try to get your estimate in p minus p n minus 1 terms. Okay, so what I'm saying is we can start with this minus p of n, and we want some constant here, and we want this kind of result, some power alpha. This is what we need. If you can show that somehow, then you can say that okay, your convergent, your iterations are converging and it's converging with order alpha. Okay, and other thing is, in just to guarantee whether your convergence will be there, you can find your g of x as, say, in the first part as 2x plus, sorry, it is 20x plus 21 upon x square upon 21. Okay, so you can start with this gx, find its derivative, and check the conditions on the derivative, whether our whether our required condition of the theorem is matching or not.
So it will not match because sufficiently close नहीं है ना, क्योंकि थ्योरम जिस हिसाब से हमने प्रूफ करी है उसमें उसका यूज किया है कि वो sufficiently close होना चाहिए.
Have you
So
tried this thing, this definition?
I don't think sir it is easy to do like that.
That is why you were given a week, that you should at least try yourself out ki how to approach this, right? So I asked the students ki what is there any issue? They said that it is solvable, so let me ask them ki what is their idea.
Sir, initial guess is 1. So
Yes,
mod of g dash x is less than 1 if uh, uh, there will be an interval for x in which mod g dash x is less than 1. Here x naught is 1, but if we calculate x1, then it will lie in that interval. So for x, if sequence will converge if we take x naught or x1, doesn't matter.
right, because what do we say, this should be greater than after sufficiently many n, right?
Yes, sir.
You will get the same issue, same problem when you will be solving question number 7. The issue which you are facing here, that okay, initial our guess is somehow far away from our exact solution, but with the first very guess, with very first iteration, you will get that okay, x1 or x2 is getting sufficiently close to your exact solution. and then you can apply the results. Because see, this result, when we say that p minus pn is less than equal to c times this result I'm talking about, this star, we say that it should be true for all n greater than equal to n. So after sufficiently many n, if this result is getting true, then also we say that the convergence hold.
But actually, how can we claim that the iteration will go to the roots? That's the problem. In question number 7, that is okay. We are claiming in the second part that x1 is greater than root 2, then we are done. But here, how can we say that the iteration will go to the close to the root?
See, you already have the root with you, right? Exact solution is given. Or
Yes.
if even if exact solution is not given, you can find it in a couple of seconds. For example, if it pn is 20 pn minus 1 plus 21 upon pn minus 1 square upon 21. So what is the best thing to do here? Suppose that for the time being, suppose that pn converges to some p, right? If there is a fixed point, then it should be true. Pn will converge to some point p if it is converging, right? So just apply the limits both side. So it will be 20p plus 21 upon p square upon 21, right? So it will be nothing but p is equal to 21 p square, or p is equal to 21 power 1 by 3, right? So in order to see whether your sequence will converge or not, this is the thing. You have some function, just put it equal to x. Both side put equal to x, you will get okay.
So, so this shows if it is converged, then it converges to this
Yes,
point.
that what I'm saying. If this point doesn't exist, suppose, then you can't even claim, because the thing is, but I'm saying, if pn converges to p, then something holds, right?
So problem is here, pn कन्वर्ज करेगा, ये कैसे शो करेंगे? ये इटरेशन निकाल के शो कर सकते हैं क्या कि इटरेशन निकाल रहे हैं?
Yes, so at least you have some p, right? If you have the exact root, and after say 2 or 3 iterations, you can get your approximate solutions to be sufficiently close. Because if I say start with this gx, my g prime x will be 20 minus 21 upon x cube upon 21, right? Minus 42, sorry, right? So now you can find your exact solution is say 21 to the power 1 by 3. So now find some neighborhood of, so if I say x star is equal to 21 upon 1 by 3, okay? So in around x star is equal to 21 to the power 1 by 3, g prime x is continuous, right? G prime divided by 21 to the power 1 by 3 is continuous, right? So you can always find some neighborhood 21 to the power 1 by 3 such that, so I am saying minus epsilon 21 power 1 by 3 plus epsilon. So in that neighborhood, G prime C mod is less than 1. You can always find such neighborhood. This is the proof of the theory, right? That's how we work in the theory, that the function is continuously differentiable. So
Yes.
once you are having some epsilon, once you're having some interval, what do you need to do? You have to just apply 2 or 3 iterations and get back to that. Okay, after 2 or 3 iterations, or maybe 4 iterations, my root, my approximate root is getting in somewhere close to my exact root. And once my say x2 or x3 get trapped in this interval, then after that I can guarantee okay, it is once one of the approximate root is very close to my exact root, so now my solution will converge. And in order, or else the best method is to start with this. one method, p minus p of n. It might be lengthy, but it will surely give you okay, if at all pn is converging and say pn is converging to p, then what will be the order?
Okay, sir.
See, I am not bounding you guys that you have to think now only. I am giving you some type of idea that how to approach. Even if in the next lecture, if you don't get the required solution with the idea given in the tutorial, you can ask me. But you guys have to try it on your own, right? You can ask me these same problems in the next tutorial itself. But the idea which I'm giving to you, try to apply that at least once or twice. Okay.
Okay, sir.
Okay. So please try question number 3 on your own now. I have given you enough idea that how can we approach this problem, how can we get the order of convergence, speed of convergence, all these things. So have I discussed in the previous lecture that in the fixed point iteration method, that how can we find the number of iterations? If I'm saying that xn is some sequence converging to my exact solution x star, then how can we find n number of iterations such that my error is sufficiently small? Have we discussed this in previous tutorial? Let me see here only. Yeah, we have discussed it. Are you guys able to recall these things? That how can we find number of iterations in fixed point iteration method? Or I need to do it again?
So please give one example of this.
Example of on how to find order of on how to find number of iterations.
Yes, sir. So
Okay.
that see how to calculate you are using.
Okay. See, in the question number 4 only we can do this. Okay. Let us do question number 4. Here we need to define a function on our own and need to find the required accuracy. So they are asking us to find a fixed point iteration method to find an approximation to square root 3. So first of all, we need to define a function, right? Such that f of root 3 is equal to root 3. So what should be the most natural function, most basic function we can think of?
X square minus 3. Oh,
X square minus 3. No, it will not give, because f of root 3 is 0 here.
fx is equal to x.
Fx is equal to x. It is the identity function. It will surely, but it has plenty of fixed points. But we want a convergence at root 3. We are close. Some
X
sort of
square
this
plus x minus
fx is equal to
x square plus x minus 3.
x square plus x minus 3. Right, this function can work. What about fx is equal to x upon root 3?
No, sir. What?
Yes.
X square upon root 3.
Yes, x square by
x square upon root 3, sorry. Right? Can this function work? Okay, tell me to which function we can start with. Make it to g. We can start with that function only. Which function to start with, fx or gx?
So x square minus root 3, why not?
Because f of what will be f of root 3?
So
You said f
f
x square minus 3
g.
initially.
So we are taking f or g.
That's what I'm asking. Which function you will say we will start with that?
So fx is equal to x square minus 3. So we are calculating its root that will approximate root 3.
See, what I'm saying is if you find the root of this, it is 0, right? So how do we start with? I am asking you to give me an fx such that fx is equal to x, or f of root 3 is equal to root 3. Okay. So this function
So 1 by
here you
x
are
plus 3
finding,
by.
yes. So this can work. Surely this can work. Even if I define it as c of x is equal to x plus c times x square minus 3. Then for all c, this function will also work. This is what we have done in question number 2, right?
Sir, for all, see how? So f dash root 3 is greater than 1 for c equal to 1, I think.
I'm not saying it that convert. I'm not asking about the convergence. I am saying for this function, fc of root 3 will be root 3. That only I'm claiming. I am not asking about the convergence because in order to get the convergence, we have to proceed it like question number 2. Right? In question number 2, we find that okay, in around some neighborhood of the exact solution, we have to have a bound, right? So that c we have to calculate okay which c can exactly work. But I'm saying that for any c, one can think of this function initially, right? We can start with fcx is equal to x plus c into x square minus 3. We can find the derivative of c prime x. What it will be? It will be 1 plus 2cx, right? Is it making sense that fcx, we can start with this function x plus c times x square minus 3. The derivative will be f prime c is equal to 1 plus 2cx. Now we have to find my values on c. So that mod f prime c of x is less than 1 for all x in some neighborhood of this. Fine. Is it fine that even this function cannot work? There is a trouble in this function because we are just taking c to be 1 here, and 1 plus 2x you will not able to bound f prime x. Is the function making sense to you guys? Which function to start with?
Yes, sir.
Okay, so suppose I am taking this function fcx is equal to x plus c times x square minus 3. Okay, so f prime c of x is 2 plus 1 plus 2c x. So f prime c at root 3, let me calculate that. It is 1 plus 2 root 3x, 2 root 3 times c. Okay, so if I substitute c is equal to minus 1 upon 4 root 3 suppose, then f prime c of root 3 is equal to 1 by 2, right?
Yes, sir.
So we can surely find some neighborhood around c. Okay, so let u epsilon, so at root 3 minus epsilon comma root 3 plus epsilon be an neighborhood such that mod f prime c of x is less than, say, 3 by 4 for all x belongs to u epsilon. Is this making sense? Can we find some epsilon? Instead of that, can we find such neighborhood? Can we guarantee the existence of such a neighborhood in our problem? See, if you are not getting how to find this neighborhood, please tell me, because if once you are done with finding such neighborhood, then most of the tutorial shit is done. Say yes or no, can we find such neighborhood?
Yes, sir.
Okay, fine. So now you have this in root 3 minus epsilon comma root 3 plus epsilon. So if I take my initial guess to be root 3 minus epsilon by 2, x naught to be, say, this, and it belongs to u epsilon, and now I can approach x1, x2 and so on, then in theory only xn plus 1 is less than some f prime c mod xn minus x of n minus 1. So now this f prime c is surely less than 3 by 4, right? Because c will belong to this interval which will be contained in this. Negative of r plus 1 by, right? This is subset. Yes. Yes. Is this making sense?
Yes.
Then what do we have? For certain n, xn minus x star will be less than c to the power mod x naught minus x star, right? Are we taking multiplication composition as fine? And we want it to be less than epsilon. So it is okay, not epsilon here. At present, we want it to be less than 10 to the power minus 2. Here C is my, this C is nothing but 3 by 4. So, and say it is some constant A. I don't care what is that. Okay. So we have 3 upon 4 power n into A should be less than 1 upon 100. So now 4 upon 3n is greater than 100 times A. So n should be greater than log 100A upon log 4 by 3. Fine. Are we good till here? This is the number of iterations. So it is not exactly the number of iterations. So I'm not saying it is the least number n such that we will have order of conversion such that the error will be less than 10 to the power minus 2. So let me write that. We are not saying that it's the least positive integer such that error is less than 10 to the power minus 2, but this n will surely be less than 10 to the power minus 2. That is there might exist some m belongs to natural number, m is strictly less than n, such that xm minus x star is less than 10 to the power minus 2. Is this making sense?
Yes, sir.
So this is what question number 4 is asking to you. We have to find an approximation to root 3. So for that we have found our function to be this as fx is equal to 1 minus 1 upon 4 root 3 x square minus 3. So for this function we can start with, okay, and then for n greater than this number we will surely have that error will be less than 10 to the power minus 2. But once we start with calculating the roots, that x1 x2 x3, then it might be a chance that for some xm where m is strictly less than n, your error is less than 10 to the power minus 2. Okay, so n is some number which will guarantee my error to be less than certain bound, but it might not be the least number. Okay, are we clear with question number 4?
Yes, sir.
Yes, sir.
Okay, proceed to question number 5. Just read the statement of the question and tell me, can we do it?
Yes, sir. Please tell the question number 6. What should be the function gx
Gx will be
in question number
some
6?
Question number 6.
x plus some c times again x plus 2 sine pi of x
What
where
will be
x
the
belongs to.
C?
For that c I have told you the trick that you need to do the derivative, go to the exact root and find some neighborhood.
I tried it, but I couldn't figure it out.
Okay, you can do one thing. You have my number, right?
No, sir.
Okay, let me. I am giving you guys my phone number again. Please write it down. Because see, this is just the calculation part. I I would like to see your effort first before telling the next statement. You can
So
send me
we
your
can take the Newton's method that will always converge.
what?
Xn minus f xn divided by f dash xn.
Yes, Newton's method you're talking about. What are you
If we
saying
take
about
gx,
Newton's method?
if we take gx is equal to that function, then that will always converge. We
See,
have proved.
Newton's method is a particular case of fixed point iteration method. If I'm saying that some xn is converging to x via Newton's method, right? That's what you're saying. So you can just
In this
define your
question,
gx to
yes,
be this
x minus
x
f.
minus f of x upon f prime x, right?
Yes, sir.
So you can surely start with that.
So is it guaranteed that it will converge? Because for Newton's method, the initial gas should be very close to the root, otherwise it will diverge.
That is to see every method has their own pros and cons. Newton's method is just going at a faster rate. That is the pros for it. But it has some cons that you have to take the initial gas to be sufficiently close, first of all, and secondly, you derivative should be defined there.
Actually, sir, they in the question initial gas is given.
Yes.
So how can we know that the initial gas is very closer to the root?
Okay, so its root will be around 1.2 something, if I'm not wrong.
Yes, sir.
It's 1.2 something will be the root. So you can surely work with Newton's method also. But I would like to see why, what problem are you facing in this thing? Because recalling a Newton's method at this stage is again risky because initial gas should be given somehow at a distance from your exact
Sir,
solution.
while solving question, we are given an initial guess. We are not given the solution. So how do we know that it is sufficiently close?
Yeah, that is true. So the thing is, when someone make a paper, they have solved it on their own and they have checked it that okay, this initial gas will surely converge because in both the cases,
We
when
will
you
given
go to the
sufficiently close
fixed point
to the.
iteration method, yes, so you don't need to worry about that whether it is given sufficiently close or not. If some initial guess is given to you, believe that it is sufficiently close and you can apply your methods.
What's the
See,
question
when we
may
give
not be found for Newton method?
what?
The question may not be formed for Newton method.
See, the question is formed for the fixed point iteration method. So you can convert, you can make a Newton's method to be a particular case of fixed point iteration method, right?
Yes, sir.
So it depends upon if it is saying that you have to go with the fixed point iteration method, then you don't have any choice. So, but again, if you want to go with the approach of Newton's method, you can define your gx to be like this because they are not giving you a particular function, right? They are not claiming that you have to start with this function and do the fixed point iterations. They are not saying that. They are saying that you have to go with the fixed point iteration approach and you have to find the solution or exact root of some non-linear problem. So now it is up to you which function you are going to define.
So I thought we have to find the function such that the image of that function should also be contained in that interval.
So if the image, if you're saying that if I am choosing some x node, so g of x1 should be in that interval only and g of x2 should be in that interval only. That what you're saying?
Yes, sir.
So if you want to work with such type of functions, you can surely have to work with this one, x plus c times, because you know that you will have some maxima or minima at your exact solution. So then you can say, okay, if you are, so the graph of such function is something like this. Okay, so I'm saying it will be my exact root. Okay, so in some neighborhood here, you can surely say that whether if my x naught is say here, so g of x naught will be going towards c. So that's why we are okay. So let me make it a exact because we are already using some constant c here. So there you need to do the increasing and decreasing part. Okay, if I'm starting with my x naught, so g of x naught is getting sufficiently close there. It is not the graph of g, it is a graph of g prime.
Similarly, in question number 3, we can assume P not equal to 1 is sufficiently close and we can use the theorems.
Yes, you can. See, the theorem is defined where if g prime is less than 1, then everything works fine. It is not claiming if g prime is greater than 1, then nothing will work. It is not claiming that. Okay. So if your derivatives at a certain point is getting less than 1, then you can use that theorem directly. But if it is not getting, then doesn't mean that your function or your iteration are not converging. So read the difference between these two statements. If g prime is less than 1, then surely your theorems can apply and everything can work. But if g prime at that point is not less than 1, then also your iterations might converge. Because as you can see that after say 2 or 3 iterations, your g prime is getting very close to your second iteration or third iteration is getting very close to exact root, or you can say at least your g prime is getting less than 1 after certain iterations. And I would like to see, I don't know who was saying that he is facing some trouble with this function. Please do text me the picture of your effort. Probably there might be some mathematical issue, some calculation issue. And if the calculation will become little bit, because I haven't solved it on my own at present, I have the idea with me. So even if it will not work, I will surely give the solution with this method in the next lecture. Okay. But I will like to see the approach key. What issue are you facing?
So,
Yes.
so correct me if I'm wrong. If g prime is less than 1 at the root, then we can apply all the theorem that we had proved without caring of that the initial guess is closer to that or not, because in the question the examiner has set the question such that the initial guess is closer to that point.
Yes, you can do that.
Okay, thank you, sir.
Shall we proceed to question number 7?
Yes, sir.
Okay, so A part is saying that the sequence is converging to square root 2. So we are doing these things only in the past 3 lectures. So can we do that? That the given sequence is converging to square root 2. And see, you don't need to do anything. You are not restricted to apply fixed point iteration method or something. You can even use your real analysis here, which you have read in graduation, say monotone convergence theorem or anything of that. You can use anything to show that this sequence is converging to square root 2. You are not bound any. You are not bound by anything. Okay. So can we show that this sequence is converging to square root 2?
Yes, sir.
Okay. So it is for x naught is greater than root 2, because they are saying this because in most of the cases when you go to the fixed point things, so you might have start with this thing, and then g prime x will be 1 by 2 minus 1 by x square. So if x naught is strictly greater than root 2, so mod g prime will be strictly less than 1. You can see that, right?
Sir, if we are using monotonic conversion theorem, then we should not care about initial guess.
Yes, you shouldn't. But I'm saying about this thing, if when you are given such type of things, x1 is equal to something, and you are doing the numerical analysis paper, so the first thing which comes to your mind might be fixed point iteration theorem. So for that you can start with this gx. That's what I'm saying. You can definitely apply monotonic conversion theorem. You just have to prove that this function is monotone and bounded, right? But in order to prove it is monotone, you have to have some initial guess, because this function is not throughout monotone. If you go to the x naught greater than root 2 and x naught less than root 2, the function will change its monotonicity. So in one side it is, say, increasing, or at one side it might be decreasing. All right. See, you can see from here only. G prime x is nothing but 1 upon 2 minus 1 upon x square, right? So if x is greater than square root 2, then g prime x is less than 1 by 2 and strictly greater than 0. But if x is strictly less than square root 2, then g prime x is strictly less than 0. So in left of root 2, your function is decreasing. In right of root 2, your function is increasing. Have I said something wrong? X is greater than root 2, 1 by x, 2. Yeah, right. So when you start with monotonic convergence theorem, if you want to apply, you have to see these things. Your function is increasing somewhere and decreasing somewhere. Okay. So if you proceed to part B, they are showing that even if x naught is less than square root 2, then also you can do the convergence part by A part only, because they assume that in A part you might have used fixed point iteration theorem. Does question number 7 make sense to everyone now? Is question number 7 making sense? Are we done with question number 7?
Yes, sir.
Yes, sir.
Okay, so it is just 4 minutes left for today's lecture. So I think question number 8, we already have an idea, and it might have done in the class also.
Yes, sir.
And question number 9, 10, 11 are the similar question which I have already proved earlier today only. they are going with the same approach. Please read all the three questions and tell me whether you guys can solve it or not.
Yes, sir.
Okay, so I will assume that assignment 2 is done from my side, but I will give you one more chance. You can ask me any doubt in the next tutorial session. Please do solve the assignment 2 on your own now. You have the idea to each and every problem by now. If you guys face any kind of difficulty, you can let me know in the next tutorial. Or else we will start with assignment sheet 3 in the next tutorial. Okay?